Hi everyone, and welcome to this afternoon's webinar on the glaciated landscapes actually outside of the UK, particularly today looking at Solheimajokull, which is in South Iceland. Thank you for joining us. Last week's CPD was absolutely fantastic and we've had great feedback, so it's great that we're able to do some of these online CBD courses and just to sort of like update our knowledge, our understanding, and actually giving you new ideas of how to sort of like develop your children and your students and give them something exciting to learn as well. I am going to turn my video off just in a moment. I just wanted to show that I am here. You'll also see that my colleague Kat is also here. She comes up as Discover the World. She's monitoring the chat box, so please, if you do have any questions at all, please just put some questions in there if you need me to answer them. She'll then relay them over to me. Give you a couple of minutes at the end as well to ask any questions that you may have, and I've also got my email at the end as well, so if you've got anything there that you would like to email me, then please do use that as well. So let's stop the video and let's get started. So this afternoon's webinar, as I said, is on glaciated landscapes. In particular, we're also looking at the impact of climate change on glaciated landscapes as well. We're going to focus on Solheimajokull, which is in southern Iceland, giving your students a fantastic case study. For those of you who don't know me, my name's Karen. I work for Discover the World Education as an education manager, and I'm also an Icelandic school guide. And prior to working here, I was head of department and pastoral deputy for over 25 years. And I continue to be fascinated by how glacier landscapes how they are and how they change from season to season, from year to year, and from decade to decade. And also looking at how these processes and landforms are impacted by people, by human activity, by the climate, the weather, and their location. And looking at that, the connections, they're really at the heart of geography, as we know, and they really form the heart of this particular topic as well. So the aims, we're going to look at glaciated landscapes beyond the UK. The case study is Solheimajokull, which is in southern Iceland. We're going to look at the glacial retreat that has happened there, as well as the impacts. And in particular, we're going to look at the historic data leading to the rapid retreat of this glacier, particularly over the last sort of 15 to 30 years. And why it is such an invaluable case study, not just for glacial landforms and processes, which you'll see we've got here, but also in terms of the impact of climate change on glacier landscapes. Due to the rapid retreat of this particular glacier, it's just perfect for students because the changes are quite quick. When I was teaching this particular glacier in the classroom, we could say that these are pictures that I took just 10, 15 years ago. So it makes it very personal, very real. It's very different from the study of other processes such as coastal and fluvial processes. They tend to be very slow, don't they? And sometimes they're quite difficult for students to perceive. But with this particular glacier, we really can see the changes. They're very, very evident. We're also going to look at a variety of exciting resources which you could use with your students. Some are great for in-class activity, others are great because, as we know, lots of independent work going on at the moment. And there's lots of scope for enrichment and extension. You'll see that during the webinar, it really focuses on connections because that's something that we truly believe in. It's something that I really believe in, that students need to have a connection to a place, because this really enhances their memory. It's all very well us saying, this particular glacier, this particular landscape, but how amazing for them to have their own sort of like trigger, their own memory, their own connection. They might not always get to go there because we can do it through imagery and through different connections. We need to generate that emotion, we need to generate the thought. So you'll see that a lot of the stuff that I talk about today is aimed at generating that emotion and generating that connection. So around about 11% of the land area of Iceland is covered by glaciers. It's around about 100,000 square kilometres. Iceland has 269 named glaciers of almost all different types. Vatnajökull, down here in the southeast corner, is the largest ice mass in Europe. And Solheimajokull is this little tongue here, which extends southwards from the Mýrdalsjökull glacial area, which is actually the fourth largest glacier area in Iceland. Its peak reaches 1,493 metres in height, and in the year 1980, it covered approximately an area of 595 square kilometres. So it is a reasonably sized ice mass. Solheimajokull, as you can see here on this next picture, it's just here on the south coast, just here. Okay, and it sits between the volcanoes of Katla and Eyjafjallajökull. And you can see here, I've zoomed in, I'm actually going to go back one image. So here, this is the Eyjafjallajökull area, and this is the Katla area, and Solheimajokull just comes down here as a tongue leading from the Mýrdalsjökull glacier area. The river Jökulsá runs down from Solheimajokull, and you can see it here, this river here. Okay, it's filled with glacial meltwater because it is actually the river that is sort of like fed by the glacial area, and it's rich with smelly sulfuric acid from the subglacial areas. Obviously there are a number of volcanoes, but particularly Katla sitting underneath this particular glacier, and sometimes it's been called the Stinky River, just literally because it does have all this sort of sulfuric acid in the river. Solheimajokull is approximately 8 kilometres long and about 2 kilometres wide. It does appear much larger, actually, just really because of the lack of boundary between the tongue and the larger ice sheet. It covers around about 44 square kilometres, and the average thickness of this particular glacier is on average around about 200 metres thick. So it is quite a sizable glacier here. Okay, so let's start by looking at the trends in the temperature for the Solheimajokull region over the last 70 years. As you can see from this graph, there is a trend for the temperature to increase since 1950. It may not seem like a significant amount, but it has a majorly significant effect on the glacier itself. And in recent years, the temperature have also been a little bit more erratic, which is also an issue from this area. Solheimajokull is also a south-facing glacier, so therefore when we do have more sunny days in Iceland, it is directly in the sunlight. This graph shows the size or the cumulative front variation of Solheimajokull. As you can see, the glacier was growing slightly during 1980 to 2000. You can see where this line is moving up, but the decrease in the size and the retreat has been pretty rapid since 2000. This second graph shows this data much more clearly. The obvious gradual retreat in the early 1900s, okay, a slight advancement between 1970 and 2000, and then the rapid retreat since then. And you can see this particular year, 2008, 2007, 2008, it really was quite significant and actually noticeable to the eye just visiting from one year to the next. These images show this retreat even more clearly. The image from Google Earth shows the glacier location in the year 2020. You can clearly see the glacial lagoon, you can see the snout, you can see the crevices and fissures in the ablation zone here, the areas of moraine on either side of the glacier, so here and here, okay, and then the glacial river, which forms going down southwards down to the sea. It's quite important here for you to notice this feature here. This is a man-made feature. This is actually the brand new car park that has been built in recent years. And it is important because I'm going to show you an image that we took not so long ago, which shows when the snout of the glacier was actually here. The yellow line shows you where the glacier used to be just 15 years ago. So in 15 years, it has retreated by 750 metres. And don't forget, that retreat is not just here, it's also in terms of on the sides of the glaciers, in the depth of the glaciers. You know, the accumulation zone just cannot really keep up with the amount of retreat that is happening at this ablation zone here. You can see here where this camera is, okay, this shows you where the next image was taken from. So I was literally sat in this car park here, okay, and the next image is here. So you can see that the snout of the glacier was literally, so this is the car park here, okay, the snout of the glacier was literally where we used to park the coach. And this was in 2008. So just 12 years ago, okay, 2008 was where that was. Okay, the red dot here is the image taken in 1998, which shows you where the car park is now. Okay, so you would have seen that it would actually be under the snout of the glacier. All right, so the retreat is not only rapid, but also quite dramatic and evident within the very short time that actually we've been travelling to Iceland. I came across a landscape photographer some years ago called James or Jim Balog, and I've been following his progress on the images and work that he's done and is doing in terms of ice and glaciers. This is Solheimajokull. Okay, his original aim was to take some stunning images of ice over a period of time, but was so shocked by the dramatic change in the glaciers in Iceland over the years that he was inspired not only to take this project further, but also actually to set up an exploration survey unit and a film documentary for the National Geographic. You know, he was really shocked by what the images showed him. He actually stated that his images were the most tangible, immediate, concrete evidence of climate change that exists today. This particular image of Solheimajokull was taken in 2007. This image was taken in 2016, okay? Both from exactly the same camera place. So he actually put his cameras on exactly the same position. Just going to go back again. So 2007, 2016. And then what I've done here is I've actually put the smaller images together so that you can really see the impact just over a period of 10 years. The retreat is so significant. You know, where the snout was, it's now a huge glacial lake full of iceberg. It measures over now 1 kilometre long. The height of the glacier has changed beyond recognition. Just look at the valley sides as well. You know, the width of the snout has shrunk by approximately 50%. James Balog, when he looked at these pictures, actually said, I'm holding in my hand the evidence of its existence, because he really truly believes that actually in not so long time really, that is the only existence that's going to be, that this glacier was actually there. The Extreme Ice Survey is brilliant. It's a fantastic sort of wide-ranging, ground-based photographic study of the glacier. And we'll look more at the resources that you can use in your classrooms and this evidence later in this webinar. Okay, this particular diagram is one that I find particularly useful for students. You can find it on our website if you haven't got it, and you can download it and use it within your lessons. So we're going to look now at the landform features and processes that are quite evident at this particular glacier. Okay, I'll use this diagram as a point of reference, and you'll find this and other valuable diagrams on sort of like the website for you to look. So for example, this one, and this one, and this one. They're all on there for you to use. Okay, one of the most significant features at Solheimajokull, due to the rapid repeat in recent years, are the evidence of deposition and the different moraines. As you can see, the material here is very, very poorly sorted. Some is angular, there's sand, there's ash, there's pebbles, there's lava, showing the origin, actually, of this particular rock. And this till was carried by the glacier and then dumped. No sorting has taken place whatsoever, and there are both lateral and terminal moraines remains very evident all around the Solheimajokull location. Freeze-thaw weathering is so evident here. The glacier, as we know, is south-facing, and it's also at sea level, which means it has the effects of facing the sun without the effects of altitude. And at night, the temperatures plummet very quickly, meaning that freeze-thaw action can be seen everywhere you look. The scree slopes dominate the edge of the valley, and large boulders and rocks, still in situ, looking rather like completed jigsaw puzzles, scatter the paths and slopes. You know, it's really fantastic. I put this picture here of some students walking along this path up to the snout, because you can do this, you know, very easily. And it's great because the kids can look either side and they can see the evidence of the freeze-thaw action literally there, you know, and they can touch it. I try not to get them to touch it too much, obviously, but what an amazing thing for them to see. You know, freeze-thaw action is very active in this particular location, and it is a dominating weathering process. In recent years, the outwash plain here at Solheimajokull has really grown and grown, and it now stretches some 6 kilometres from the sea to the glacial lagoon, and we'll look at that next. Here you can see that the glacial river, Jokull, has picked up the material and started to sort it. It's still quite angular as it's only been a short amount of time in the stream, so the processes of erosion, you know, attrition and abrasion haven't really had the chance to show its true effect. But you can see the difference here in the sorted material that's been on the outwash plain and the angular, sort of like jagged, unsorted material from the till that we find in the moraine. And I think this image is particularly good to show sort of like students the difference in the material and the processes that are going on. So if we look particularly at the snout at Solheimajokull is now a 40-minute plus, depending on how quickly you're walking, walk from the car park, which just seems incredible to me, you know, when you can stand with it just 20 metres, you know, just 15 years ago. And here you can clearly see features of the ablation zone with evidence of carving. More evidence can be seen of the retreat process here, with the rivers actually starting to appear from under the snout, forming these little mini lagoons before it eventually comes into the full sort of like major glacial lagoon a little bit further on. But these are great examples that the students can use and great images that you can use actually to teach this particular process. So the main glacial lagoon at Solheimajokull, as you can see from this picture here, has really grown and grown in size. This image is actually taken from the glacier itself, looking just over the snout. So I was just literally sort of like entering the ablation, or, you know, just coming up to the accumulation zone, but just on the edge of the ablation zone, really, looking out to sea. Where my arrow is now is where the snout used to be just 10 years ago. And then it was here 15 years ago. And this is actually where the car park is now. Now, as carving takes place from the snout, the glacier continues to retreat and the lagoon starts to really, you know, really develop in size, really, and icebergs really start to appear in the lagoon. And during the summer and the spring, this lagoon is often filled with different icebergs of all different sizes. What I find particularly fascinating about some of this is you can actually really look at these icebergs and you can see sort of like the ash and the rocks that form in the icebergs, and that's kind of really showing a history as to where this ice has come from. And I just want to go back, because some of this ash here is not like we would think from the Eyjafjallajökull eruption of 2010, but actually from the Katla eruption of 1918. So it really is quite fascinating for the kids to, you know, the students, sorry, to look at this particular glacier and maybe do some critical thinking, some extended thinking on this. You know, what is that black material? Where has it come from? You know, how old could that material be? What could we look at the material and see if there are differences in ash? Because there really are. If you look at the Katla eruption, then actually that's a very different density and a different ash to the Eyjafjallajökull eruption. So it gives you the opportunities to have some great sort of like enrichment extension activities for the students here. Okay, so due to its shape and direction, the accumulation zone is easily seen from the valley floor on the Solheimajokull eruption location. This area of equilibrium does accumulate heavy amounts of snow and ice, but the lower temperatures at the ablation zone does mean that it can't really compensate for the retreat that is currently occurring. You can see these images showing the fissures and the cracks that appear in this particular zone on Solheimajokull. Okay, whilst this area doesn't yet show the typical U-shaped valley and the corries that we see in the UK landscapes, glaciated landscapes, there are many hanging valleys and other geological features in the valley sides which are clear. As can be seen from this image, there is evidence here of the lava flows. Just here you can see where my arrow is. So that's showing all the different sort of like volcanic eruptions that took place before this glacier actually invaded this particular valley. And you can see that there are mini gorges going down sort of like on the side of the valley. There are some hanging valleys as well. And then you can see the evidence of fluvial processes as well. So whilst we don't really quite yet have the U-shaped, you can kind of see it, but it is getting there. But obviously there are other glacial and tectonic features that can be used by the students here. Okay, see here some of the extra processes. Along the edge of the valley, very, very visible in many areas, are the striations caused by the erosional processes of abrasion. And you can see them in this image here, and then again here as well. And these clearly show the direction of the flow of the glacier as it edged slowly down towards the sea. The rocks which have been deposited along the edges of the valley are jagged and sharp. They haven't yet been eroded and weathered by other natural elements, so they're therefore the real signs of the plucking that happened from the glacier. And because it is quite a protected area, many of these sort of like signs and evidences are still here, which is why it's so good as a case study for your students. And I think the images also really show that as well. So let's now move on from Solheimajokull a little bit and take a broader view on climate change and the impact of this on the various glaciers in Iceland. We're still focused on Solheimajokull, but I'm also going to use some other examples to help you see sort of like the actual impact on this particular Arctic region. We all read the stories last year about the Siberian heatwave and the record temperatures in these regions. So why? I think this could be a really good extension activity for your students, and also another one that could be used to develop their critical thinking skills, because there are lots of interesting reports and theories behind this. We know that air temperatures across the Arctic have been increasing at a rate that is about twice the global average. So you can see here the blue line is the Arctic temperatures and the red line are the global ones. And obviously all that heat has consequences. Siberia's recent heat wave and the high summer temperatures in previous years have been accelerating the melting of Arctic permafrost. And Iceland in 2019 permanently lost a glacier called Ork. Now, evidence shows us that the glaciers and ice sheets in Iceland, as well as in other Arctic areas, are shrinking and retreating at alarming rates. Scientists have developed many models of global climate system. They're called the general circulation models for, GCMs, and they reproduce the major patterns that can be seen in the weather observations. Now, this really does help us track and predict the behaviour of climate phenomena such as the Indian monsoon, El Nino, and the Gulf Stream. And they've been used to project sort of like changes to the climate in the world, you know, particularly with more atmospheric CO2. And we've been really looking at this since the 1990s. A common feature of these models is the polar amplification effect. And this is where the warming is intensified in the polar regions and especially in the Arctic. The amplification can be between 2 and 2.5 degrees. So, you know, as we said, for every degree of global warming, the Arctic will see double or more. You know, and it is a robust feature of our climate models. And it's interesting to see why this does actually happen, you know, so why the Arctic temperatures are increasing at such an alarming rate. Fresh snow, as we know, is the brightest natural surface on the planet. It means that the solar radiation, 85%, is reflected back out to space. The ocean is the opposite. It's the darkest natural surface, and this only reflects around 10% of radiation. So in the winter, the Arctic Ocean, which is covered in sea ice, and then the sea ice has the snow on it, it's a bit like a huge thermal blanket protecting the dark ocean underneath. And then as temperatures rise in spring, the sea ice melts, which exposes the dark ocean underneath, which absorbs even more solar radiation, which increases the warming of the region, which melts even more ice. So this is a positive feedback loop. It's often sort of referred to as the ice albedo feedback mechanism. Really, it's to do with snow, but it's particularly potent in the Arctic because the Arctic Ocean is almost landlocked by Eurasia and North America. It's less easy, for example, compared to Antarctica, for the ocean currents to move the sea ice around. So as a result, the sea ice stays in the Arctic for longer, but it's been sort of like declining really since 1970s, around about 13% every 10 years. There's quite a lot of evidence actually to indicate that the sea ice hasn't been as low as it is for the last, you know, now as it is in the last 1,500 years. So it really is quite significant, really, what's happening now. In other words, you know, these record-breaking temperatures that we saw last summer, they're not really a one-off, and they're actually part of a long-term trend that was predicted by climate models actually decades ago. Today we're seeing the results, you know, permafrost thaw, sea ice and ice sheet melting, you know, and I read an article the other day that actually described the Arctic as the canary in the coal mine for climate breakdown. And I think we can rightly say, you know, it's singing pretty loud, this canary, at the moment, and it will get louder and louder, I am sure. I wanted to show you some more visual stimulus from the different Iceland glaciers, really, to show the impact of this rapid increase in the Arctic. This is the bird's eye view of the Solheimajokull glacier in 1982. This is the glacier in 2017. Put these images together. It is quite dramatic, the difference. You can see that the camera angle is exactly the same. You know, this isn't even the snout of the glacier here. It's getting towards sort of like the snout, but it's not quite there yet. And look where it is now. And if I put my cursor over where the snout is, it's now here. Okay, a significant retreat on this particular glacier. Now, landslides and paraglacial activity are going to become more and more of a common occurrence in glacial areas due to climate change. They can be devastating, and we've seen real evidence of this, haven't we, in the last 24 hours or so. I'm sure that we saw the news reports yesterday, and I'm sure there will be some more today in the Himalayan region yesterday that followed this landslide due to the glacier breakage that collapsed into this dam. And these images are just awful, and they're a clear reminder of how dangerous these areas can be. And our thoughts really do go out to everybody affected by this disaster. And we'll look shortly at one way that scientists are looking to monitor this paraglacial risks so that communities like the ones close to the Himalayan regions can be better prepared for this. You know, this Iceland glacier, the Solheimajokull glacier area in Iceland, is one that's showing real paraglacial activity. There are several large cracks in the slopes around the glacier, and they've been discovered. And if they were to collapse, they could cause a landslide of material in excess of 60 million cubic meters. This area is very obviously currently closed off to all visitors due to the risk, and it's being closely monitored with drone and laser equipment. And you can explore the progress of this particular glacier on the Icelandic website vedur.is, and I've put the link there, and you'll be able to gain access to some of these links at the end of this particular webinar. So I now want to give you some, hopefully, inspiration and resources that you may wish to consider using for your students. There are a number of podcast videos, GIS resources, images, newspaper articles, books, all of which are relevant to the curriculum and also for any extended individual study that you may wish to set your students. I've already mentioned the website vedur.is, but there are a few others which are really good for independent investigation and have lots and lots of different interesting articles, papers and summaries on the work that's being done in Iceland and around the rest of the world in terms of monitoring the glaciers and looking at them in terms of trends linked to the impact of climate change, and obviously looking at forecasting for the future. I particularly like the ones, this one here, the World Glacier Monitoring Service is brilliant, and we're going to look at that in a little bit more detail in a minute. Vedur is obviously very obviously linked to the Iceland glaciers, and that has lots of fantastic information as well. And then two other groups, the British Geological Survey and the US Geological Survey. They've also got some very interesting information on their websites as well. I want to go back to James Balog, just literally because of the imagery that he can provide your students. But James's images in ice are incredibly beautiful, and they're exactly what the book's subtitle says. They are portraits of vanishing glaciers. They are the record of a unique landscape rapidly disappearing. Showing these images to students, I think, because of their dramatic and stunning imagery, really generates emotion and discussion. What a fantastic way to start a lesson, and getting them to be completely fascinated with what is going on in these quite fragile environments. Jim, in his introduction of his book, says that the irony is that we have the technological and economic means to make a difference. And what we really need is the will and the sensibility. He says that we have all this free energy coming down out of the sky, the sun and the wind, that could be used with zero environmental consequences. And actually what we need to do is actually throw the gauntlet down and actually take this on board. And I do think that the current generation of teenagers really is. They are throwing, aren't they, the gauntlet down and saying, come on, what are we going to do about this situation? From his studies, he initiated the EIS, the Extreme Ice Survey, which actually collects data on the seasonal changes of glaciers so that we can learn from it, that we can look at the trends, we can see what has happened and what is going to happen. We can slow the changes down and perhaps even start to reverse them. Chasing Ice is an amazing National Geographic documentary. It actually documents his trip to the glacial environments of Greenland, Iceland and Alaska, capturing these images and help convey the effects of global warming. He spends a lot of time in Iceland. What's actually very interesting here is that he was initially quite skeptical about climate change when it first sort of entered the scientific discussion. But after his first trip to Iceland, he actually became completely convinced that the impact that we have on the planet is actually quite bad at the moment. And he becomes quite committed to bringing this story to the public. And it was in just a couple of months of his trip to Iceland that he did actually start this Extreme Ice Survey, where they've put all these cameras and different instruments around sort of like the Arctic to actually capture what is going on. The documentary is brilliant. His images are fantastic. He's also got a great TED talk, which is sort of like short and to the point, which also I think is really good. So he does have quite a lot of resources that you might find quite interesting in your lessons. And I've actually put some of the links there for you. Okay, just moving away just from Iceland just for a minute. I watched a fantastic documentary just at the end of last year, which I think may be particularly valuable for your students, particularly after what happened yesterday. And it is ironic, isn't it, that the day before I'm doing a webinar on sort of like glaciers and climate change, and then I watched this sort of documentary at the end of last year, and then there does unfortunately happened to be a disaster in that particular area. It's a bit surreal, really, but it is obviously very relevant. And it's called Expedition Everest. It's a combined UK-USA expedition. It involves a number of scientists who are looking at climatic and environmental data on the Khumbu Glacier in the Himalayan region. This is the glacier that actually leads up to the summit of Mount Everest. It's only a 40-minute documentary, and it tracks the progress of these scientists as they place weather stations and other scientific equipment on the glacier in order to document and monitor the changes. Drones, thermal imagery, as well as laser measurements are all used, and the data that's collected and collated by the weather stations is being used to help to prepare, plan and predict for the future. As you probably know, over 1/4 billion people are reliant on the fresh water that's stored in the ice in the Himalayan region. It's difficult to comprehend, 1/4 billion people. So it's really invaluable to look at the patterns and trends of the ice or water storage in order to prepare for the future. And then really following on from the disaster yesterday, another way that the data and evidence is being used is to develop monitoring systems for the people living in the shadow of these glacial areas, because we know that the flash flooding is becoming more of an occurrence. Nobody anticipated the one yesterday, and perhaps a good and effective monitoring system could have prevented some of the impact of yesterday's disaster. And then finally, it's hoped that these weather stations will give a more accurate weather forecasting system. So therefore, the huge amounts of people that are hoping to climb Everest, hopefully it will also protect some of those climbers in years to come as well. So let's go back to Iceland, look a little bit more at James Balog's Extreme Ice Survey. So we've already talked about some of the great resources that he can offer you. And the one thing that is of particular interest for this particular webinar is the time-lapse video that is available on his website from 2017 to 2016 of Solheimajokull. It's incredible, absolutely incredible. I really, really encourage you to watch it. It basically takes images from April the 1st, 2007 to June the 16th, 2016, and you can really see the glacier, advance and retreat during that time. You'll also see the impacts of the 2010 Eyjafjallajökull eruption, because it obviously turned this usually blue-white glacier quite black from the ash that was released from the volcano. So again, quite an interesting time lapse to watch. Another interesting resource is this podcast on the BBC World Service. It's part of their assignment programme. It takes the views and opinions and memories of local people in Iceland. It's great for independent enrichment tasks, particularly for your auditory learners, because you really hear the glacier, and it is quite an interesting thing to listen to. Really good. We've already mentioned Ork. This was the first Icelandic glacier to lose its status as a glacier. It was well documented within the different media sources. There's plenty of articles that you could use with your students, and again, really benefit and develop their critical thinking skills, because it is said that in the next 200 years, all Icelandic glaciers are expected to follow the same path as Orc. There was a monument which was put on the place where this particular glacier was, and it was there to acknowledge that we need to know what is happening and what needs to be done. And the monument is there for the future because it's saying to the person who's reading it, only you know if we did it. And this particular monument was designed by a poet, an author, a writer called Andri Magnusson, and he wrote an amazing book called On Time and Water. This is another book that I really, really recommend. It's great, absolutely great. His letter to the future was basically about, you know, are we going to look after these glaciers? It did make global news and was shared by millions. And his book actually attempts to come to terms with the issues that we all face. He's also completed a TED Talk. It's only 3 minutes long, but it is a wonderful stimulus for your students. And what he says is, over the next 200 years, we can expect all of the Earth's glaciers to disappear unless we act now. You know, he says and explains why we need to start connecting to the future in a more urgent way in order to stabilise the Earth for generations to come. Highly recommend that. It's really good. GIS, as we know, are great tools to show students the fluctuations of glaciers, as well as developing their skills. And the WGMS have a wonderful tool on their website, Fluctuations of Glaciers. It's great as a standalone topic or a subject stimulus, or just great for independent study. Another good resource that you could encourage your students to use is Gis Iceland on the Discover the World Education classroom resources page. It's a very easily accessible tool which enables users to experience the glacier, as well as giving them some interesting nutshell information on the glacier itself. The imagery is fantastic. It's done by drone, as well as sort of like standalone images as well. And it will really give the students an idea of what this glacier is like. The GIS Iceland doesn't just focus on Solheimajokull. As you can see, there are over 40 different sites in Iceland that you can also go and have a look at as well. Now, not a paper that I would normally take general interest in, but this particular article by Dr. Kieran Baxter from the University of Dundee did catch my attention. And Dr. Baxter's very personal report on the changes of the glaciers in Iceland uses photographic evidence to show the dramatic changes since 1989. There are two reports. Both are very visual, so they give the students that emotional connection through imagery. One was published just last week and the other was at the end of 2019, so they're pretty up to date. The report is also available on the BBC News website, but there's less interactive imagery there, so I actually felt that this one is more useful and stimulating for the students. As you can see, two images are displayed, and then the arrows allow you to scroll across so you can see the real differences over the years. I've tried to screenshot them to show you. The second and third shot that I've captured are probably the most dramatic, and there's about 7 or 8 within the sort of like the source that you can use. So this one I feel is quite dramatic, and then this one as well. This one particularly shows the height and the difference in the width of the glacier. This is quite a good independent task for the students to do, and great for your visual and your kinesthetic learners. And then finally, the award-winning resources that you can gain free access to via the Discover the World Education website. There's a short case study video presented by Simon Ross. It's 20 minutes long, together with quite a lot of diagrams, of photographs and lesson suggestions. We've also got some tools to assist your students in how to speak and write like geographers. And we've also got a brand new resource which has only just been released, the Glaciology assessment maps. And these are free to download from our website, so you can take a look at those. These are the examples of the Glaciology assessment maps. So you can see they come blank. You can just print these off and use them in your classroom. There's another one. And then obviously we give you the answers as well. So you could use it in a different way should you wish. So finally, I hope that this bit has been valuable. You can access all our previous webinars via our website. Our most recent one was another A-level topic looking at changing places, in particular Quevergurdy. There are also some webinars on there on energy, tectonic processes, rivers, coasts, sustainability, tourism. They're all free for you to access via our website, so please do use them. You may also be interested in our revision webinars, which are specifically designed for students rather than as a CPD opportunity. We've already had one series of 6 different webinars, which have been very, very sort of like widely used. They're available through our website, and then we've got 2 brand new ones at the beginning of March, which again, they're free, able for you to access, and you can share the link with your students as well. Just sign up via the website and we'll send you the link. As I said, if you've got any questions at all, please do either ping them in the chat box now, or just drop me an email. My email is here. If you would like a copy of the PowerPoint as a PDF document, please do email me on this particular email, and I will send that over to you within the next few days or so. And it's just left me to say thank you very much for joining me this afternoon. Take care of yourselves, and I hope to see you again very shortly. Thank you.